Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques.com. In this video, we're going to take a look at Cramer's rule and we're going to use it for solving a system of equation that involves two variables. So let's go ahead and take a look at this. So, in order to do Cramer's rule, you have to understand determinants. And we've talked about determinants in a prior video. And so basically how it works is that you take the determinant of something divided by the determinant of something to get x, and you take the determinant of y divided by the determinant of the whole system to get the y value. And so here's kind of what it looks like in a theoretical sense, and then we'll do a practical example after that. So let's see here. So here's what's going on. You have your variable, we'll just call this a1 plus, let's see here, b1y, oh I'm sorry, I should put an x in there, a1, this should be an x right here, excuse me, a1x b1y equals the constant k of 1, alright? And then you have your a2 1x plus your b1, b2y equals your constant of 2 right there, like so. So this is what we have here. Oh, I need to delete that. Excuse that for a second. And so we got a a2x, a1 of x, b1 of y equals k1, a2 of x plus b2 of y, k2. Those are what's happening. So in this particular situation, what's happening is that we have coefficients. A is a coefficient, b is a coefficient. That's what's happening. X and y are variables, as you can probably tell. And then we have k as our constants. That's what's happening here. And so when we want to do this, we want to first set up a determinant. And so the determinant is going to be, the first one is going to exclude the k's. And we call that capital D, like this, like so. And then what happens is that you have in here, you have your A1, your A2, your B1, and your B2. This is your first determinant. That's how it works. Now, d of x, your determinant, or your determinant of x, or you can call it d minor x, however you want to think about it, is going to be like this, capital D, and then you're going to have the x like so. And then in order to do this one, let's see here, you exclude the x values, I believe. Yes, you exclude the x values. So, and you replace them with the constants. That's how it works out here. Yeah. So you have your k of 1 here, k of 2 here, b1 of b of 1 and b of 2, like so. This is it. So notice how in this particular example the x's are gone. Instead we have the constants that have replaced the x values. Because remember, the first column is our x values, the second column was our y values. Here is the constant, and then you have the y value. And so to finish this, to do the determinant of y, if you will simply take, you'll have your a1 values again, a1, a1, a2, but now you'll replace the b column or the y coefficients with the constants. And so you'll have your k1 here, and your k2 like so, like this. This is kind of how you're setting it up. And so when you want to finally figure out what is the value for x, let me put this in a slightly different color here. When you want to finally figure out the value for x, it's very, very simple. You take the determinant of x, I guess the minor of it, and then for y you do the same thing. You take the determinant of y minor, I guess if you want to call it that, with d, like so. And that'll give you your final values. Now, we've talked about this in a theoretical sense. Let's take a look at this in an actual example. So what we're going to do now is I have my system of equations. So I got 3x plus y equals -3. And then I have my 2x plus 3y equals 6. Now, let me just point out what's happening here. These guys right here, these are my a coefficients. This guy right here, well, there's a 1 here, but you don't need to put the 1 here. These are my b coefficients. And then, of course, this guy and this guy, these are my constants. So I got an A1 and an A2, like so. So this will be on 1, this will be my 2. I have a B1 and a B2, and then I have a constant 1 and a constant 2, like so. That's what's happening. Now, the first thing we're going to solve for is we're going to solve for D. So this is just capital D, like so. So D, and when we do the matrix here, it's going to be A1 and A2, like I already told you. So 3 and 2, and then B1 and B2, which is going to be 1 and 3, like so. So as you remember from prior videos, we have to cross multiply here and then subtract. So 3 times 3 is going to be 9. And then 2 times 1 is going to be 2. So we subtract 2. And we get the value 7. This is our D. Okay, so moving on here. Now we're going to do D of X. So D of X, let me just draw a nice little line so there's no confusion. dx, like so. Now for D of X, we're going to replace the A's right here, the 3 and the 2, with the constant. So when we do that, we get negative 3. Oh, let me draw my line here. Negative 3. Oh, let me give you a negative 3 like this. And then we get 6 on the bottom. These are the constants. I replace the X value with a constant. And then I have 1 and 3. Those are the same Y values. We cross multiply again. And so negative 3 times 3 is negative 9. 6 times 1 is 6. So you subtract 6 like so. And you get a D of X that equals negative 15. So you can see here we're making great progress. Okay, I got a little bit more space. So I'll just draw a line right here. And we're going to solve for D of Y now. So dy minor, if you want to call it that. And so this time I replace the Y values with the constant. So I have 3 and 2 back in my first column, the original X values, but this time I put negative 3 and 6 in the second column here. And so we do the same math that we did last time. I take 3 times 6, I get 18. I take 2 times 3, I get negative 6. So subtract, and it's going to be a negative 6. And so I think you guys know how this works. These two negatives work together to become a positive. And so I have a D of Y that equals positive 24, like so. So I have my 3 values now that I'm going to use for my next step. This is what I know. D is going to be 7. This will be my denominator when I do the final math. Then I have a negative 15 for my X, and then I have a 24 for my D of Y. That's what happens. Now I just want to show you something that I don't think oh yeah, remember right here, this is what we use to actually solve the actual values for our where the two equations intersect. We take D minor X, D minor Y over D. That's what we do. So we know our numbers here, 7, negative 15, and positive 24. Let's go ahead and do this. So my X value, I know the bottom number is going to be 7. My Y value, I know the bottom number is going to be 7 because if you remember, D equaled 7. Now for X, you can see that our value here is negative 15. So I put that value right here in the top, negative 15. And then for our Y, it was 24 in case you forgot. So this tells me very simply that my X is going to be, or let me write this as interval notation here, our standard notation. It's going to be negative 15 over 7, 24 over 7. This is where the two lines line up. Now, just to make sure that this is clear, we're going to go ahead and see if we can put this in the computer, or I'm sorry, in the calculator, and see what we find here. So, my original equation was 3 times negative 15 divided by 7, okay, plus 24 divided by 7. All right, let's see here. What do we get? And we got -3. That's what we should have got. And so we know that this system of equation worked, but we can just verify it by doing the second equation. So 2 times -15 divided by 7, like so, plus 3 times, 24 divided by 7. And hopefully this will equal 6. You can see right there. So we know that our system of equation works. Now let's review what we did so that we can wrap up this video. So here's what happened in this video. We started by looking at Cramer's rule, which is a very practical way of utilizing determinants to solve for a system of equations. And remember, when we're solving for a system of equations, we're trying to find out where the two lines intersect at if we were to graph them. And so what's happening here is that first you find the determinant, where you take the x and make that the left column, the y make that the right column, and you just take the coefficients for that. Because remember, we don't know x or y, so we take the coefficients. And that's what we use to find this guy right here, the determinant. Now we need to find the determinant of x. I guess you can call it the minor if you want the technical terms. And what you do for d of x, dx if you will, you replace the x coefficients, so that's the a's in this situation in our theoretical example here, with the constants, which is the stuff to the right of the equal sign in our example here. And so instead of having a1 and a2, you have k1 and k2. And then you solve accordingly. I'm assuming you remember how to deal with that because we talked about that in the prior video. And then lastly, you deal with the determinant of y, or y minor, whatever you want to call it. This time you replace the y values with the constants. All right? And then to finally solve for x, you put the determinant of x over the determinant, and for solving for y, you take the determinant of y over the determinant, if you will. That's how you do it. And so when we went through this exercise, we were able to find our three values. The determinant was 7, d of x was -15, and d of y was 24. And we took this information and we plugged it in as so. This lower number is d of 7, d equals 7. We talked about that. This -15 was d of x. We talked about that. This 24 was d of y. And then we were able to finally get our answer right here. This guy right here. And then we put it into the calculator and we confirmed it. And so that's the beauty of Cramer's rule. Whether it saves you time or not, oh well, you can argue with mathematicians about that. But this is another way of basically using elimination with determinants to solve a system of equations. So I hope this was useful for you, and I look forward to seeing you in future videos. Take care.